purpose of the paper is to discuss the role of embedded networks in Australia and how they're evolving into microgrids. Now, embedded networks are generally privately owned networks that interact with a distribution company. And the key conclusions are that embedded networks are popular in Australia. We have a lot of them. Primarily, they're done to reduce the price, but also they can also be used to reduce emissions or incorporate solar energy or other demand response. This example is an isolated microgrid which is being run by Horizon Energy. This is actually an operating distribution network, and they've got, each household has demand response associated with it. So we've got solar panels, batteries, and air conditioners with a primary load because it's very hot where they are, and each of those managed, and they're optimised to manage the load of the house, and then the entire system is balanced with solar farms, batteries, and a balancing generator. Now, the objective function of the entire grid is to minimise the cost of the gas, so reduce the emissions. So that's that particular one. So in Australia we have a separate legislative framework that allows networks to be exempted from the regulation, and that's how it works. And this is an example of a university. Now, the university's established a microgrid. Now, it's operational, but it's only early stages. They're at stage 1. It is funded by the Australian government to assist it, and what they're doing is they've got a number of buildings that they've established onto this grid using separate control systems which are provided by Indra Energy, which is a large utility in Spain, and managed by the GreenSync balancing system. And they've got they've got a lot of 22 kV substations. They've got a large peak demand, 3.5 megawatts on the site, but they're putting in 1.5 megawatts of solar. They're building EV charging, and they're going to put in a 1 megawatt hour battery. And that's going to be used to balance this site. Their intention is to reduce the site to zero emissions. So while they want to reduce their cost, the primary purpose is zero emissions. And the last one is other microgrids, which is, this one is a DSO, so a distributor has established a microgrid where they've got a control system on the edge of the microgrid, and they're balancing off the supplies of batteries and solar panels. And they can actually run this microgrid independently of the grid if they choose to, or connect it to the grid. And the grid can provide services such as voltage support back out to the main distribution system, but their main role is so that this gets more reliable supply, and they can actually get a cheaper service and a more reliable service, because if the main grid goes, this microgrid can operate independently, and that's how it's designed to work.